All right, we're going to get started right away. We want to honor your time. Thank you for coming in. We're actually very excited to have you here. We're all going to get on the same page today. Woohoo! Okay, I should introduce myself. I'm Patty Sankey, if you forgot. And I'm at Templeton Middle School, and I'm one of the coaches. And you guys know me, I'm Kathy Drago, coach in the district. Okay, so this is part of the work we did this summer. We did some background on cross-cutting concepts, which is another component of NGSS. You guys are getting that in November. And today we're going to talk backward design and the rubrics that have been created so far. So you're ready for next week, Friday, when we continue this work at the in-service day. All right, so reminder, we have revised our curriculum cycle to be a 5-year process, and K-8 science right now is in year 2. So year 1 was that research and review year, and everyone in science, the curriculum team really did a deep dive into standards. The whole district science teachers did some background knowledge on the practice standards of the NGSS and the framework of the NGSS. They started creating rubrics. And then we're in year 2 now, and the curriculum team is continuing to pilot resources, continuing to create rubrics, starting to think about what does that alignment look K-12. And then we're continuing PD as a K-8 science team around standards and how this implementation is going to look for year 3. So I always like to honor the work that we do. So actually, it's been a year since we've been together and since you had professional development on the practices. So we came to the conclusion that you probably don't remember all of them all at one time because it's been a while. So no fear, we're going to review and then talk about what the rubrics look like. Okay, so quick reminder, the biggest change with the NGSS, or one of the biggest changes, is that science and engineering are given equal weight when we teach science. And so in science, we want to focus on explaining phenomena and focus on inquiry, so asking those questions. And science is about finding the one answer to the question. Why does it rain? Why does our stomach make noise when it digests food? And then engineering is the application of what we've learned from science to focus on design and solve human needs. So there's multiple solutions, and we want to be focusing on both those components in our science classrooms. And then another reminder, the NGSS is 3-dimensional, so there are 3 parts to the standards. There are the practices, which is like our toolbox, how scientists and engineers approach the discipline, what they use to learn about science and engineering. You have the disciplinary core ideas, which is what scientists and engineers know, so that's what we think of when we think of the content, volcanoes, erosion, human body. And then we have the cross-cutting concepts, which is how they synthesize what they learn. So scientists and engineers use the practices to learn the content, and then they synthesize it through the cross-cutting concepts. Okay. All right, so those practices again, we have asking questions, defining problems, planning and carrying out investigations, analyzing and interpreting data, developing and using models, constructing explanations and designing solutions, engaging in argument from evidence, using mathematics and computational thinking, obtaining, evaluating, and communicating information. So this summer, when the team came together, what we did was we reviewed these, and then we said, we would like to have a universal language across the district. So it's not just about students who are new to our district, but also if I have a student that's moving from Lannon to Maple or from Maple to Woodside, that they see common language and universality around all of our buildings. And so in order to do that, we had come to the conclusion that it's important to investigate why it is that scientists and engineers use these practices. Reminder, these are the same 8 practices K-12. So right. No matter what classroom you're in, you're hitting these practices. They just build on each other and become more complex with each year. So at your tables, this is what they built this summer. So this one is a K2. This one or these 2 over here are 3-5. And so what you'll see is the why behind why scientists use this practice and why engineers do. So each poster has a different practice on it, and then alongside has the definitions of the why. So we'd like you to just take a few minutes just to look over them and to remind yourself about the why.